How do you design a better endodontic file?
In order to design a better endodontic file, we first have to define and comprehend its functions. Simply, the functions are: first, to form dental chips from the canal wall, to dislodge the chips, and to transport the chips from an area of file engagement to an area of file disengagement. The file tip initiates these functions, and from that aspect, it is the most important. But it is also the most vulnerable part of the file due to a small cross-section area. The tip should be able to form and dislodge the chips without screwing in, to transport the debris without the debris becoming compacted in its grooves, causing undue abrasion and torsion, and to guide the instrument around curvatures without forming a ledge or transporting the canal. The One Endo File addresses these problems in ways that contrast to conventional file designs. Unlike so-called safe tips that have to burnish their way into a canal that is smaller than the tip itself, the One Endo File has a flute that extends through its tip, providing a blade that cuts rather than burnishing its path. However, opposite the blade side of the tip is a smooth, rounded surface providing a pilot to guide the tip around curvatures. Consequently, the tip cuts, then flips, then cuts and flips its way around curvatures. The One Endo File has fewer spirals at its tip to avoid the screwing in effect and the propensity for breakage found in most every other files. This configuration enables the file tip to undergo greater plastic deformation. This feature also reduces the distance the debris has to be transported around the spirals, thus decreasing torsional stress while enhancing the file's ability to collect debris and avoid pushing it in advance of its tip. At the tip end of the file, the cross-section is symmetrical, and each cutting edge projects equally from the file center. As the flutes progress from the file tip to the handle end, the cutting edge projects proportionally a greater distance from its central axis than the opposing cutting edge. Dissimilar tapered flutes integrated into one instrument enable the distribution and the orientation of the cutting edges to increase cutting efficiency and reduce friction and torsion. This may seem counterintuitive, but the results speak for themselves. The results are a reduction in the overall torque loading, enhanced cutting efficiency, greater flexibility, and more efficient debris removal. Debris removal is more effective since all cutting edges are not simultaneously engaged. The cross-section area decreases proportionally toward the handle end of the file and increases the area for debris elimination. In addition, the cutting edge that does not engage the canal wall as forcefully as the opposing edge acts to break up the debris, facilitating its removal. Our attention to detail has accomplished our objective for the One Endo File's design to achieve better results when compared to any other file of comparable size, independent of the technique being used. You only need to substitute the One Endo File, most closely matching the size, and taper the files you are currently using to expect better results. No technique change, only results. The design is patented and is the One Endo File.